To start an engine, on the Boeing 737. A number of tasks, in a checklist has to be followed. The ones directly concerning engine operation are: aircraft's electrical power, has to be established, for operation of two computers, that plays a vital role in a successful engine start. Electronic engine control, located on the right side of the engines. And display electronics unit, located in aircraft's electronic compartment. Fuel pumps of the aircraft, have to be turned on. This transfers low-pressure fuel, from the fuel tanks, to the engine spar valve. In order to crank the engine, pneumatic power is required. 3 sources of pneumatic power can be used. By connecting an external jet starter unit from the other engine, if it's running, or from the APU, which is the standard practice. Ignition switch position has to be changed. For redundancy, each engine has 2 ignition system, left and right. Standard procedure requires to change the switch position before each start. Now that the engine is configured for start, turn the engine start switch to ground start position. A solenoid, controlled by display electronics unit, latches and holds the switch. The start switch now sends an electrical signal to the start valve on the engine fan case to open. The pneumatic power reaches the starter. The starter, which is an air-driven motor consisting of turbine, reduction gears, and clutch, turns the output shaft of the accessory gearbox on the engine. The output shaft of the gearbox turns the N2 rotor of the engine, on which are mounted high-pressure compressors and high-pressure turbine. N2 rotation induces air suction into the engine. As a result, the N1 rotor of the engine, on which the fan, low-pressure compressors, and low-pressure turbines are mounted, begins to rotate marginally. Speed sensors send the rotation speed of the N2 and N1 rotors to DEU, which displays them in the cockpit. The N2 reaches 25% of its maximum RPM. The engine has now reached the maximum motoring stage. Now move the start lever from cutoff to idle position. The start lever causes engine fuel spar valve to open, and fuel reaches the engine shutoff valve. The start lever also sends an electrical signal to the electronic engine control. The EEC commands the engine shutoff valve to open, transferring fuel to the engine fuel pump, mounted on the accessory gearbox. The fuel pump increases the fuel pressure, and transfers it to the fuel metering valve. EEC now controls the rate of fuel flow, by controlling the fuel metering valve, which transfers the fuel into the combustion chamber, through the fuel nozzles. At the same time, EEC commands the ignition exciter box to ignite the fuel-air mixture in the combustion chamber, with the help of igniter plug. The combustion increases high-pressure and low-pressure turbines rotation. This shoots up the N1 and N2 rotors RPM. Thermocouple sensors send the exhaust gas temperature data to the EEC. EEC monitors engine parameters, and if it notices any anomaly, immediately cuts off the fuel supply and ignition. At 56% N2, the engine reaches a self-sustainable level. The DEU removes the ground from start switch solenoid, and the switch goes to off position. This removes the power to the start valve, which closes to stop the pneumatic supply to starter. The reduction in pressure reduces starter speed, which disengages the clutch, isolating the starter from the engine gearbox rotation. As the temperature inside combustion chamber is enough for continuous fuel-air mixture ignition, EEC deactivates the ignition system. Now the engine has reached the idle stage. In order to increase the engine thrust to high power, move the thrust lever ahead. Resolver sends an output voltage, proportional to the thrust lever angle, to the EEC. The EEC, according to the position, increases the fuel flow rate, through the fuel metering valve. By supplying more fuel for combustion, the EEC increases the thrust of the engine to maximum power. To shut down the engine, move the thrust lever back to idle. This will decrease fuel flow for combustion, and the engine will go back to the idle speed. Then move the start lever to cut off. This will stop the fuel flow, and the engine will gradually come to an halt.